What's up, YouTube? Time for another topic that will grab your attention. My plan is really simple: to teach you how seniors think about the solution and why a concrete problem requires generics. This tutorial is unique among the others because we are going to explain things through the problem-solution aspect. We have some problems, and by using generics we'll somehow resolve them. If you want to practice custom generics like a senior, this tutorial is the only one you need to watch. That sounds right up my alley, so let's dive in. Well, before diving into code examples, let's see what we have in our agenda. Repository implementation with custom generics, service layer implementation, common algorithm implementations with custom generics, and of course, boxing, unboxing, and the solution. The purpose here is to help you to understand why and when, as a senior developer, we are applying custom generics in our projects. What I learned throughout my career was everything is really easy to understand if you have a good mentor to explain it. Okay, let's meet our first problem. It is about the repository implementation. If you don't know what repository is, this is also not a problem. Let's see what repository is. Long story short about repository pattern. Repository decouples business logic from the data access. So in our layered architecture, we have some type of data access, we have business layer, we have UI layer. The actual data access helps us to isolate our data access processes from the business logic. It makes more modular and maintainable code. It improves testability. It also allows us to change data access technologies like data providers. For example, if you are working with TransactSQL and if you want to change your data provider to the PostgreSQL without affecting to the clients, it is completely okay to implement it using repository. And also repository helps us to support for caching strategies and loosely coupling between layers. I guess it is enough theory, and let's start with the solution. In our solution, we have multiple projects, and one of them is actually our common project. The common project is actually a class library. We have some type of models, and we are going to use these models in all our other projects. For that reason, I created a common as a library, and I put all the domain models to this common project. So I have domain entity. This is going to be our abstract model. It means the inherited classes will have ID created and updated as a properties. We have author that encapsulates name and description, and also we have article that encapsulates title, description, author ID, is deleted and is published. All of them, both models are inherited from our domain entity. That's actually all about the common. And we have repository. In our repository, we don't have any implementation. The purpose here is to encapsulate data access logic. For example, if you want to store some information in your file, in your database, in your other third-party web service, it doesn't matter. You should encapsulate the logic inside the repository. And the repository will help you to change your data provider from the, let's say, TransactSQL, from the PostgreSQL, or from PostgreSQL to the file, and etc. For the article and author, let's say we have a database, and in our database we have articles and authors table. For now, to make these things really simple, I'm not going to implement the tables per the models. I will just use in-memory data structure for them. For example, for the article, let's have article repository. Add class article repository. For the article repository, I'm going to have two methods actually, and they are going to be get asynchronously and list asynchronously. So public task article get asynchronously. All the models inherit from the domain entity. For the domain entity, we have ID. So let's give it ID. Okay, let's add our article, and let's also create some type of in-memory data structure here. Private, read-only, list, article, and let's call it articles. Cool. For the articles, I'm going to articles equal to list article, and here I am going to have only one article, simple title and simple description. Of course, ID, like generated ID. And let's implement our get asynchronously. Let's use task from result. If you are actually going to implement data access like using entity framework, so just inject the entity framework DB context to your article repository and use the built-in functionality rather than task from result. But for now, I'm using in memory data structure and I need to use task from result. Okay. Articles, let's use first article ID. Cool. Now let's implement list. For the list, I am going to have this type of signature without any argument, and it should be an enumerable article. And let's remove this filtering stuff and replace it with as enumerable. Well, that's actually all about our article repository. Now in our article repository, we have two functionalities, get by ID and list all articles. Now I want to implement the same behavior for my actual author. So right click, add class, author repository. Okay, for the author repository, I realized that we have completely same functionality. We need to retrieve author by ID. We need to list our authors. So we have the difference here is the only type we are encapsulating, the only type we are storing in our database. So in our database, we have two tables. We have article table, we have author table, but we have the same query mechanism for all these tables. So for the article, we have insert, update, delete, select. For the author, we have insert, update, delete, select. So the only difference here is the table and it is columns. Let's copy this functionality from here and let's replace it with author rather than article. Okay, let's copy. Paste here. Let's rename it. Authors, cool, new author, doesn't matter. Let's just remove it. And for the constructor, let's have the proper name. That's actually all. We have now our author repository and we have article repository. Okay, let's compare them. As a developer, it doesn't matter if you are senior or junior, middle, it doesn't make sense. What we are going to do, we are always trying to solve the problem. Okay, first try to solve the problem, then try to apply the design patterns, design principles. So we solved the problem. Now we have two completely same behavior in our application. We have two repositories, but with completely same signature. The only difference here is we are returning article here, but here we are returning author. But all other mechanisms are completely same. What I'm going to do actually, after comparing them, I think to have different implementation for my repository. The purpose here is when you have your repository, it means you are going to change your implementation in the future. For example, if you are using in memory structure, in the future we are going to use Transact SQL, PostgreSQL, and etc. For that reason, I'm going to create an interface for it. Okay, right click, quick actions, extract interface, and let's have auto repository. Okay, for my auto repository, I have two public methods. I have author-based implementation. For that reason, we have our auto repository. But when we have the approximately same signature for our article, let's have it. Okay. And if I compare my interfaces, I realize that I have two completely same functionality. The only difference here is getAsync returns author, here it returns article, IEnumerable author, IEnumerable article. The rest of the things are completely same. I don't want to have two repository interfaces for that. I want to somehow commonize them. I want to have one single signature for my repositories. So what I'm going to do, actually, I'm just going to copy. It doesn't make sense to copy from the article or author. Just copy it. Right click, add new item. Right click, add new item. Let's have it as a repository. Okay, for iRepository, now we have get and list, but my iRepository concretely returns article rather than author. So how it is possible for me to have one single signature for all different types? If you have the function combinations, if you have multiple functions or one function for different models, and the difference here is the type you are returning, you are accepting, then you should use generics. So let's do it. For the repository, I don't want to return article. I actually don't know what type to return. For that reason, I am putting here T. So T means type. You can call it any with any name. It doesn't make sense. And let's use iRepository T. Cool. Now I have one common repository for all repositories. What I'm going to do, actually, I'm going to remove iAuthor repository, iArticle repository. Let's go for article repository and replace it iRepository with article. Cool. Now everything is working. Let's do the same operation for author. And for the author, I'm defining that it should work with author. That's actually all. You see, it is really, really easy. The first thing you need to check that if you have the common functionalities, and the difference here should be the only type you are returning or you are accepting as an argument. Cool. And now I want to have the third repository. It is going to be, let's say, at class user repository. It is my user class. I'm not going to add anything. I just want to have user repository here. User repository. The problem here is I defined some type of contract and I want to have repository only for that types that inherit from domain entity. Right now, my user doesn't inherit from domain entity, but for me, it is completely okay to have iRepository user. It is a big problem for me because I have some type of contract in my application, but this functionality is working. So how to make this repository how to make our generic interface to work only with domain entity inherited classes. It is also completely easy. So you need to have some type of constructions using where. So you are defining that where T should inherit from domain entity. Domain entity. It means now the T that you define like article, user, should inherit from domain entity. Now let's go for user repository, and now it is not working, and it indicates that the user should inherit from domain entity. Let's have another constraint. So I just want to have, let's say, at class int repository. Actually, there is no value to have such type of repository, but in my application, without defining this constraint, system allows me to have integer repository. So let's write it, repository integer. This is completely wrong logic, so let's implement it. Let's fix and let's implement. Now it is working. If you are not going to define some type of constraint in your generics, the system will allow to work with other models also. So the first thing here is to think on solving the problem. The second is to compare your different implementations to define the common functionality. And the third one, when you come across to use generics, try to apply always constraints. Now it is working, but I will not have integer in my database as a table. This is a completely wrong repository for me. What I am going to do, actually, I am going to have where t like a class. That's actually enough for me. And now the integer repository will fail because our integer type is not a class. But if you want to add more better constraints, just apply the domain entity that encapsulates having a class instead of value type. So in this case, we have more constrained environment in our repository. That's actually all how we are as a senior implementing the custom generics in our repository layer. Well, let's switch to our second problem. It is about the common service layer implementation. First things first, let's try to understand what is a service layer. Long story short about it, so we have the clear separation of concerns using the service layer. We are handling cross-cutting concerns, making code more modular and maintainable. It helps us to improve testability. It helps us to encapsulate the business logic, actually integrating with external services, loosely coupling between layers, and transaction management. Of course, it has a lot of benefits rather than I explain it there. But for now, it is enough to understand that the business layer acts as a wrapper over our data access, and helping it, we are able to add the business operations over the database access. So we are clearly encapsulating our database and business logic. There is no need to write the business logic directly inside the data access, mix all this logic. So we are isolating data access and service layer implementation, and it helps us to easily test business logic, and helps us to isolated way to test data access and the business operations itself. Now it is time to talk about the service layers. The service layer actually acts as a wrapper over our repository. So we have a repository. We don't want to mix the repository logic with our business logic. So for that reason, we are creating a separate abstraction called services. The services will actually encapsulate the repository with additional business operations. In our domain, we have article and author. I'm going to have a right click, add class. For the article, I'm going to create article service. The actual article service will help us to work with the article repository itself. For now, I'm not going to make our project complex. For that reason, I will just show you the signatures for the article service. In article service, I'm going to have the actual two methods. The one is going to be add, the other one is actually going to be get asynchronously. So for the article, I don't want to, not just for article, but for the service layer, I don't want to throw exception, because the throwing exceptions make our contracts invalid, because it is not possible to understand from the first glance what are the methods are going to do in the service layer. For that reason, I will use the result pattern here. So public result, and it is going to be article model with string. It means for the success, I will return article. For the failed, I will return just exception message as a string. Of course, it is better for you to have not just string, but some type of domain error here. But it is out of scope. So for now, the string is enough for us. So let's add synchronously. And for the add method, I'm going to use, it is actually going to be a task. And I'm going to use the article model itself. So what I'm going to do here, that actually check for some business logic. add to repository. Okay, that's actually how we are planning to implement it for the service. And the other method is going to be the public task. Again, I result the article with string, and let's call it get asynchronously using grid ID. Cool. I'm just going to throw not implemented exception. Same is applicable for our add functionality also. This is how we are in a classical manner working with service layer. Actually, I'm not going to create some type of abstraction for the direct article, but when I start to work on another service called author service, I realize that my application requires the same type of behavior to work with author. So let's copy from the article service. Let's paste it, yeah. But for now, like in our repository, when you try to extract interface from this article or from this author, let's make it to work with author rather than article. Okay, author. I realize that the only difference between these services is actually the type I am providing here. So, yes, in this case, we are going to create a generic service contract for author and article. So, we'll do some type of we'll create a folder, abstractions, right click, add new item, iService, let's call it. Truth be told, I'm not a big fan of creating such type of interfaces. But anyway, for now, the purpose here is just to explain the custom generics. So it is completely okay. Let's copy this and paste it here. And for the author, I'm going to have some type of service T, and let's replace T model. I think that's all. Yeah. For the service layer, it is possible for you to have a service type of interface. So let's implement a service with author. Cool. Everything is working. Let's copy the same for the article. And it should be article. Cool. Now we have common contract between our services using generic implementation. So where else we should implement custom generics? This is about common algorithm implementations for custom generics. We'll implement custom generics for serialization, deserialization, for the iteration process. If we want to apply a common algorithm for all classes and models, it means you have model independent functionality, some type of algorithm. And if you want to implement model independent functionality, you should choose custom generics. Also, we use custom generics for storing information like array, list, dictionary, as we implemented for the repository, for the searching algorithms, for the specific sorting algorithms, and etc. So there are a lot of quite interesting aspects of applying custom generics, and in this tutorial I will show you one more example related to custom generics, and it is going to be the serialization process. For the serialization, I have XML serializer, binary serializer, JSON serializer. For the first implementation, we'll go with XML serializer, and in the next will be required the binary JSON serializer. For that reason, we need to implement iSerializer as a contract for the XML, JSON, and binary. We'll have the implementation of iSerializer. Actually, all these serializations have the common signature, like serialize with domain model. But for the domain model, we'll use generic mechanism. And for the next subtopic, we'll talk about why we should avoid using objects or abstract classes in the argument of methods rather than using generics. As we already learned, there is no need to implement the generics, apply design patterns, design principles before implementing the specific requirement itself. So you need to first implement the working version of your requirements, and then it is okay, and you must apply the design principles, patterns, or whatever you want to apply to your application to make it more readable, understandable, reusable, and maintainable. I'm going to implement first XML serialization process. For that reason, I'm going to create XML serialization class. For the XML serialization class, I'm going to have this type of signature. It is going to be public string, of course, serialize. Okay, serialize. And I'm going to serialize my article for now. For the XML serialization process, I want to use built-in class for the serialization XML serializer. Okay, system XML serialization namespace. Okay, serialize, XML serializer, type of article. Cool. Now, using var string writer, I am going to have a string writer. Why I don't want to serialize my data to write it to text or etc. I want directly return it. For that reason, I'm using string writer. Okay, using XML text writer. Okay, XML text writer, XML text writer equal to XML text writer. Okay, and XML text writer, let's place it. Cool. Now I have XML text writer, and of course, let's formatting intended. Okay, cool. And XML serializer dot serialize writer article, and of course return string writer to string. Cool. That's actually all about our serialization. Now I just want to check if everything is working or not. For that reason, I'm going to, let's see, console application, right click at project reference. Let's say we have all the references here. Now I'm going to the program. I want to create some article here equal to new article. Let's instantiate simple title, simple description, and give it new ID. Okay, and let's use XML serialization, new XML serialization, serialize article, string serialization response, and let's type it to console, and console dot readline. Okay, readline, control ATD. Cool. Okay, now let's run our console application and see if everything is working or not. And we have some exception. Article said because it is not have a parameterless constructor. Yeah, we need to have a parameterless constructor to serialize this thing. So let's have a empty constructor. Let's run it again. Cool. Now we have serialized article information. Cool. Let's apply the same empty constructor for our author. Of course, you can use any third-party library even without using this type of empty constructor mechanism. But for now, the simple serialization using XML serializer is enough for us. And what I'm going to do, actually, I want to specify different mechanism to serialize not only article, but also author and other classes. For that reason, I need to check first. I need to have at least two implementation of my serializer. First for article, the other one for author. And I need to compare what are the differences between them? The differences are obvious. We have only type-based difference here. For that reason, I'm going to have T and T with model. And let's do it like model type of T, and that should be okay. Now let's go to the XML serialization. Let's define article here. Article. And that's all. It should serialize the article. Let's see. Well, cool. Everything is working. And let's create our author to check if things are working for author also. Author, and let's instantiate my author, my description. Cool. Let's define XML serialization for author, and let's serialize the author here. Okay. And let's run and check if everything is working. Cool. As you see, everything is completely working. This is how we are implementing the generic functionality for the serialization, deserialization, and etc. type of common algorithms. And for making things more abstract to support not just XML serializer, but also different type of serialization, I need to have generic interface here. New item, serialization. Okay. Let's have a generic serialization. Let's just copy this and paste it here. And that's actually all. Let's inherit from serialization. And to support constraints like not providing integer, float, double type of things to be serialized, you can use constraints like this. For my case, to have domain entity will completely okay. Let's run it and check if everything is working. Cool. Voila. Everything is completely working without any issue. Well, that's actually all about the serialization process itself. Well, the last section of our tutorial is going to be the boxing unboxing process itself, and we'll explain what's wrong with boxing unboxing and why not to use non-generic collections. In my case, I have non-generic collection called array list, and this array list allows me to add any type of information I want. So in my case, I have added 2 through Simon as an information to my array list. The actual my list instance as an address lives in stack, but the whole information lives in our heap. So when I add stack-based information to my array list, it is actually going to be boxed to object and moved to heap. So we have some type of transmission here. When you add, for example, 5 to my list, system will package this 5 as an object and move it to heap. And when you want to retrieve this 5 from this list and use it as an integer, you need to retrieve it as an object and convert it to integer. Actually, this process is calling boxing unboxing process. Let me show you in the real world example. So we have array list here. In my array list, I am going to add, as you can see, it is object, nullable object, and it means I can add any type of information I want. So let's add, for example, 45. Now in my list, I have only one element. What if I want to retrieve this information? So I'm accessing to the first element of my array, and I want to retrieve it as an integer because I encapsulated it to the array list as an integer value. So let's get this value. The problem here is the array list actually returns object rather than integer. Why? Because when you add 45 as an integer to the array list, it already encapsulated to object and move it to heap. Now, if you want to retrieve this information, you should additionally do the casting process to the integer itself. This is actually the performance issue. This is really bad. Don't use array list in your applications. If your application actually works with the legacy code or it requires to interact with the COM, then it is completely okay, but otherwise use the list instead. Now, okay, cool. Let's see the value, console.write line, the value, and see the result itself is read line. Let's hit F5 and see if everything is working. Cool. Now I have 45 as a value. So as you see, we have 45 to array list. We are adding it, but when you add, system encapsulates, takes your integer, packages it to the object, and stores in an array list. If you want to unpackage this information, you should definitely do the up and downcast process from the object to the integer itself. Now, let's try to understand the boxing unboxing process itself. Boxing unboxing is not a type safely operation. It means you can add any type of information to your array list, but this is really big problem, because if you want to apply some type of functionality to the complete type, it will fail for another type. For example, in my case, let's say I have integer value and I have here some type of string value. In the for each mechanism, I want to convert this all information to the integer. So I have string. It is not possible to convert it to the integer. This is not a type safety operation. The other one is a performance. Actually, when you package your value to object and unpackage it from the object, it makes a really big problem from the performance perspective. And also from the functional perspective, it is really not a better way working with the collection, because you always should take into account that you have some type of integer value, you need to do some type of casting and etc. From the functionality perspective, it is also a big problem to work with this type of lists. So when you have the generic version of this list, it requires you to specify only the concrete type. And now it is a type safety operations. You can apply any type safety operation for it. For example, you may do some mathematical operation or etc. type of operations to apply to your list elements. Well, that's actually all. If you like my videos, please don't forget to subscribe, hit like button, and share if possible. See you in the next lessons.